Hello guys, and welcome to another episode of electrotechnology. So now we have another example which we have to find many things, including the average power, which is the P, apparent power, which is the S, reactive power, which is the Q, and the power factor, which is known as PF. Okay, so we also have to find two other questions, which is the total power and the reactive power, something like that. So now let's start with the first question, which is to find the P, SQ, and PF. So for the first one, we have the bulbs. We can see that there's 12. Number 12 represents the number of the bulbs that is in the load, that is in the circuit. So we multiply 12 by 60 watts, which means that the total power that we are having is 720 watts that is in that load. So in this case, we do not see any VAR, which means that we do not need to have any kind of Q, which is automatically it's S equals to P, and it is equals to 720 W, watts. So for this Q, we also have to write it because they also ask for us. So it's 0 VAR, and the PF is P over S as normal, which is 1 because there's no Q, or you can just write it as 720 over 720 is 1. Okay, so now let's move on to sorry, it's not B, it's actually number 2, which is the heating element, which is in the circuit. So the heating element that we have here, they already gave us the 6.4 kilowatts. It is right inside the picture that they already give us. So we can finally find S, which is the same as the first one, which is the bulbs. There's no Q, there's no reactive power, and the PF is 1. It is the perfect, the ideal type of the thing that we want to have in our house, because the power factor is so perfect. It is 1.0. So then we move on to the third part, which is the motor of the circuit. We should know that 1 HP horsepower is equal to 746 watt. So we should know how to convert from HP to watts and watts to HP, and that is something that the basic thing of conversion in electrical exercises. So we have the motor, which is the P prime. I choose it to be P prime because it is related to the factor, the N factor as well. So yes, we know that P equals to that N multiple by PI. So now we want to find the PI, which is the original P5, which is 5 HP, convert by 746 to the watts, so that we can calculate the SI, the standard units, SI units. So we get the number, which is around 4,548.78 watts. I'm sorry, it is supposed to be watts only. Yes. Sorry for the previous question as well. It's supposed to be only watts. There's no kilowatt because the conversion is from watts. So it's supposed to be only VA. Okay, so now let's move on to the next one, which is we have to find the S from it, because it is already given factor 0.72, but it says that it is lagging. Laggings mean inductive load. So when it is inductive load, it means that it is supposed to be positive only, plus sign. Okay, so when it is plus sign, we can find it actually does not matter in finding the apparent power, either it is plus sign or minus sign, because in the end it matters in the imaginary part, which is the reactive power of the complex number writing. So now we have the S, which we can be found from PF, the power factor, which is around, oh wow, that's a lot. That's 6,317.75 VA. Okay, so now we can find the Q, which is so easy peasy, which is S square minus P square equals Q. Yes, I am right. So just substitute the number, plug in the number as usual. It's very easy for this kind of exercise. Okay, so let's move on. Don't hate me on this. Okay, so let's move on. We have the number which is 434,384.355 VAR. Because it is the reactive power, it has to be R at the end. Reactive. R for reactive power. So for the last part in the circuit, it is the capacitive load. This is the complicated part because we have R and we have the capacitor. We have the resistance and capacitor that is connected together. So it's really giving a headache for us to calculate because it's not a direct method. So we have the capacitive load. I need to change the color to be more darker so you can see it more clearly. Okay, so as I said, capacitive load has a negative Q, negative reactive power. So here we have the capacitive load, that is, we need to find the power, which is from the I square R. It comes from the P equals to IB, but IB is V equals to IR, so it's I squared R. And we also have another one that is P equals to I squared X. Actually, it's not P, it's actually, it's the same power, but for the R, it is the true power, the average power, but for the X, we're finding the Q, the reactive power from the capacitor. So it's the imaginary part because it will be very small. All the capacitors, like the unit is in micro, it's 10 to the minus 6. It's really small. So yeah, so we have to find the VRMS, which is the not to find, it is where the I comes from. So here we have given the VRMS, which is in the source of it. The source of the circuit, it is 208 volts, which is in polar form, not in rectangular form. So we have to again convert and reverse to get the final product of the calculation. So here we go, we find it, and the Z is 9 minus J12. Why? Because 9 is the resistance and J12 is the imaginary part, which is the capacitor. So it's 12. And why is minus? Because it is a capacitor. Capacitor is minus. It is like almost already the common sense that we have to remember that capacitive always has to be minus. So here's a quick note for you guys to know that how to convert in case you forget. So you cannot use a calculator in exam because the teacher wants you to actually explain where it is from. So R is from the square root of x squared plus y squared, and the zeta is from the reverse tangent of y over x. Actually, you don't need to have the absolute value because you need minus and plus sign as well. The absolute value only applies in some sort of equation that we need to find in some other types of topics. So now we only need the R of it is 13.87, because when we have gotten the answer, it would be in the polar form, so we have to convert it into rectangular, and we only need the real number, the real part, not the imaginary part. So here we go, and the Q is as I said earlier, it is the XC, which is the capacitor, so it's 12 ohms as well, no matter if it's capacitor, because it is a capacitive reactance, so the unit is in ohms as well. So we have the number of the power and the value of the reactive power. So it is very easy to find the S, the apparent power, by using the Pythagoras theorem. Is that right? Yes, it is right. So here we go, that we can have S is equal to the square root of P squared plus Q squared. As usual, we plug in the number and we get the number that we are we are finding for the apparent power. I need to do some little calculation by the calculator. Sorry for the delay. The clock is ticking. Okay. I don't want to have any dead air, so here's the number: 2885.60534 VA. Sorry, it's actually VAR, the reactive. So please everyone, please don't forget to don't forget the units, because they are the same power but the units are not the same. It's like VAR, and watts. Like, what's the point of having different units for the same power, but actually it's not the same power, right? So please be careful and make sure that you get the right unit for the right type of power, which is a headache for us to actually check it in the exam. Well, yeah, okay, so PF, yeah, it's very bad. 0.599. Wow, very bad lah. Okay, so next move on to the actual B question, which is to find the total everything. Find the total true power, find the total everything power. So now we have plus all the P, the true power, together. As I mentioned in the previous video, that the P can be subtracted, can be added together, because it doesn't matter. It's just the straight line. It's not the hypotenuse. It's like we can plus and subtract together. We have that number, which is a lot. Of course, we can convert to kilowatts if you want, but you don't want to like, you know, wrong in just the conversion, so just keep with the original number that you get. So now you can also plus and minus the Q, the reactant power. So in first and second one, we have 0 Q, and we have the Q actually in the C. So we finally have the Q, which is the inductive, because the word is lagging, and then we have the capacitive word, which is the minus. So here is why the leading and the lagging keyword is really important in finding the Q. It's not important in finding anything. It's important to find the Q only. So please remember that lead is for capacitive and lag is for inductive. So here we have ST, which is the total apparent power. We have that lot of number put into the square root, and then we get the final product of S. And you have to check that actually the right number S has to be larger than P, but P and Q, any one is larger. It doesn't matter. It actually matter, because the Q cannot be actually higher than P, like normally that we have seen in the example. So yeah, we do not want it to be that way. So we all have found everything else. The leftover one is to draw the power triangle, which is very easy. Just have draw it from the answer that we have already found earlier, which is the P total, Q total, and S total. So just make sure that the Q has to be really short. It's like around 1.0 1/5 of the P because it's very very short, and the S, yeah, if you draw the P right, if you draw the Q right, so the S is supposed to be right. So just label everything that you need to label there, and that's the end of the example. So have a good day. Thank you. Don't forget to write the title of the answer. It is C. Draw the power triangle. Okay. Bye bye.